So in this lecture, we're going to go over the first set of practice problems. Since this is our first set of practice problems with natural deduction, I'm going to go through these relatively slow. So sorry if it becomes a little bit monotonous at one point, but the idea is to help you out, especially here early as much as possible, and then once we get going, we'll speed it up a little bit. But so these will go pretty slow. So first thing I'm going to do is just put some line numbers here. I already know how many line numbers I need. I'm going to need only 3. But remember that the first thing we do after we give ourselves some line numbers to work with here is just list our premises here in the first lines. So M arrow L and M. And we're going to mark those with A's. Remember, this is our justification area. And our justification for writing our premises are that they are assumptions. And then from there, we want to assign a number, a premise number here, which is 1 since this premise appears here at line 1, 2 since this one appears at line 2. Now, this is a quick proof because if you remember our rule for arrow out, it says that if we have a conditional statement, something with an arrow, as our main operator, and we have the left side of it, then we can go ahead and derive the right side. So I have a conditional statement here. I have its antecedent, or its left side there. And so I can go ahead and write what's here in the circle. And when we go to justify it here, we're going to look at where these two pieces come from. This piece comes from this first line. This second piece comes from this second line, so we will cite lines 1 and 2. And then, I'll get rid of those just to clean up a little bit. What's our rule that we use? Well, we used arrow out. Why did we use arrow out? Because our main operator here is an arrow, and what we're doing is we're removing the arrow. We're freeing the L from the M in the conditional statement. And our last step is to provide the premise numbers here. Since I have a 1 next to a 1 and 2 next to the 2, I'm going to write 1 and 2 here. And that is it. So there is our first proof. And again, it's the simplest version of the arrow out rule just by itself. So there is the first one. So now moving on to the second problem, same thing as before. I'm going to start out by listing some numbers here. This one, I haven't looked too closely at it. I'm sure I probably won't need more than 5. And the first thing I'm going to do is I'm going to look at my premises. I've got 2 of them. P, arrow, Q, and R. I also have P by itself. These, since they are premises, I'm going to write an A next to them. An A stands for assumption. But we just reduce it down to just the letter A. This premise is at line 1. This premise is at line 2. All right. Now, what are we looking for? We are looking for R. That's going to be the last line in our proof because that's our conclusion. Now, the next step should be, where is the R at in my premises? Well, I have the R right here. And now I'm thinking, how am I going to get that R by itself? Well, the first thing I'm going to have to do is I'm going to have to eliminate this arrow, because the main operator here in the first line is the arrow. Again, this is why identifying the main operator is very important when we're doing proofs, because you can only use the rule on the main operator. So our main operator is a arrow, and our arrow rule says I have a left side, I have a right side. Do I have the left side somewhere else in the proof? Well, yes, I do. I have it here in the second line. And so since I have the conditional statement here, and I have the left side or the antecedent here, then I can go ahead and get what's in the circle. And I have to write everything that's in the circle. I can't just write R. I have to write what's in the circle. So I'm going to write Q and R. Now, erase this. What was the rule that we used? Well, we used arrow out, and we used arrow out on lines 1 and 2. Here is our conditional statement. Here's our left side or our antecedent. So from those two, we can use arrow out and get this. So we're not done yet. We still need to get to R because that is what we're trying to prove. So I'm going to erase some of this stuff. So here we have a conjunction. Our main operator is the ampersand. And an ampersand says that I have a square on the left-hand side and a circle on the right-hand side. Those are called our conjuncts. And whenever you have an ampersand, you can just write whichever conjunct that you're wanting. Oh, sorry. Should have remembered to put our 1 and 2 up here. Line 3. Just remember, justifications are coming from 1 and 2, so that's why we have to put 1 and 2 there in line 3. But back to line 4 here, we're just removing this conjunct. And our ampersand out rule is just that. Actually, you could write one or the other. Doesn't matter which one. So we only need to cite the one line because that's where our ampersand is at. So the ampersand's in line 3. And what are we doing? We're removing that ampersand. And now what's the number? What numbers do we have next to line 3? Well, we have 1 and 2. And now that we've reached our conclusion, we are done. Now, just a point to mention here. In logic, you're allowed to have things that you don't necessarily need. And why I say this is because logic is following a step-by-step process. And say that you wanted to write Q here because you wanted to remove the ampersand and you wanted to write Q here. You definitely can because that's what the rule says. This rule says that if you have an ampersand, you can take either side. So if you want to write Q here in this line, you'd still cite 3 and out and 1 and 2. Now that's not our conclusion, but you can write it. And then you can write R down here citing the same rule as before, like that. This line in the proof is really not needed. It doesn't help us out at all. But that doesn't mean that the proof is wrong. It's just saying you have an extra step. But as long as you follow the rules in logic, that's completely fine to have steps in your proof that aren't needed. The reason why I mention this now is because once we get to more complicated proofs, you might just say, let me just use whatever rules I can in this situation and then see where I go from there. And that's totally fine. You can break down the proof to its simplest parts and then try to construct it back to whatever you're looking to conclude. And if you don't use some of the parts that you break it down into, that's not a problem as long as you follow the rule. That's all that matters. So you don't need this, but if you write it, it doesn't make it wrong. So that is our second problem. Here on problem 3, I'm going to do the same thing that I've done on other ones. I'm just going to start listing some numbers. I'm going to list extra numbers on this one because I'll show you that it doesn't really matter because we can just always erase them if we need to. So same starting point as before. You have premises here, and you just want to write them in the first lines of the proof. You want to mark them with an A for an assumption, and you want to identify them with whichever line they appear on. Now, let's look at our conclusion. Our conclusion is an R and a Q. And, do I see R and Q written like this anywhere in our premises? The answer is no. You might be thinking, well, here's Q and R. Isn't that the same exact thing? It's very close, but it's not exactly what we're needing. Instead, we're looking to have R and Q, and it's important that we go for exactly what we're looking for, not something that's just close. So, at least that tells us something about what we're going to be doing here. This is just a little roadmap to what we're going to be trying to do. Since I don't see this conclusion anywhere written exactly in the proof, I know that I'm going to have to build it. So I'm going to have to use ampersand in at some point. And I'm going to need to find R by itself. And I'm going to need to find Q by itself. So this is what we need to do. Now, one of the best things to do when you're doing a proof is just look at what you have to begin with. What can you do with the information that you have? Well, what's here in the first line? Well, the first line is a conditional statement. I have an arrow as my main operator. Do I have the left side of that arrow? Well, yes, I do. I have it here in line 2. So, from an arrow and from having the left side, I can write the right side. So I will. Q and R. So, how did I do that? I got it from lines 1 and 2. What's the rule that I used? Well, the main operator here was an arrow, and I was removing it, so it's arrow out. And then putting the two premises that are located next to it, I put them here, like that. Now, erase this. Remember that we are looking for Q by itself and R by itself. Well, I almost have it right here, but I don't have it exactly. I need to just get it down to Q by itself, R by itself, and then build it. So I have this ampersand, and our ampersand out rule says that if there's something with an ampersand, I can just take one of the sides. So I'll take this Q, and I'll write it here. What line number am I getting that from? Well, I'm getting it just from the ampersand here on line 3. I'm removing the ampersand. I'm getting rid of this ampersand and just saying, I just want this. And so what numbers appear here next to 3? Well, 1 and 2 appear here. Now I've got one part of the thing that I'm looking for. Now I just need to get the R. Well, the R is right here, so why don't I just use the same rules before? Separate the R from the ampersand, and then I'm going to cite the same thing as before, 3 and out. The premises next to 3 are 1 and 2, same as before. And now I have the other thing that I was looking for. I was looking for this R, and now I just need to build it together. Do I have both pieces? Well, yes, I do. Now I have these two. So I just need to put them together, R and Q, like that. And where am I getting that from? I'm getting the Q here from 4. I'm getting the R here from 5. And what am I doing? I'm introducing an ampersand between them. And now let's look at numbers 4 and 5. They both have 1 and 2 together. So that's all we need there. And now we've arrived to our conclusion that we were looking for up here. And we're done. And since we're done, we can just erase this number 7 here. Didn't need it. That's totally all right. And that would be the third problem. All right, start the same way as we have on previous problems. Just start by listing a bunch of numbers. It's down to 8. Put our premises that we get from here in the first 2 lines. those as assumptions. We'll assign them the number that they appear on and the line that they appear on. Now, what are we looking to prove? We are looking to prove m and n. Do I have m and n anywhere? Well, yes, I do. I have it right here, exactly in the same way as it's written in the conclusion. So that's going to tell me that I just need to get this arrow removed to get m and n, and I'll be done. So I have a conditional statement here in the first line. Again, main operator is the arrow because I got parentheses around the p and q, parentheses around the m and n. Now our question should be, do I have this left side? The answer is no. I don't have it anywhere. I need it written exactly like that, and I just don't have it yet in the proof. So how do I get to p and q? Well, I get to p and q by building it with p by itself and q by itself. I need p somewhere by itself and q by itself somewhere, and then I can use ampersand in. Well, how am I going to get that? I can get that from here. I have an ampersand here, so I can break it apart. I'll put the q here. I'll cite line 2 because that's where my ampersand is. What am I doing? I'm removing the ampersand from this one. And then I'm just going to do this same time because I'm using the same exact rule on the same exact sentence. So this justification will be the exact same. And because the justification is the exact same, the premise number that's associated with 2 will go into both of these, and the only premise number that we see in line 2 is number 2. So we'll put 2 here, 2 here. There is no 1 here. If a 1 was here, then we would look back up here, but there isn't a 1 there. We're only looking at the premises that give us what we find in line 2. And the only premise that is involved in line 2 is the second one. So now we've separated these two things apart, and we are looking to build P and Q. We're looking to build our left side of our arrow statement here in line 1. So how do we build it? Well, we've got the two pieces. Now we just need to put them together. I'm going to erase this one up here. So looking at this, this is what we are needing. We're needing the P and Q. So P's my left side, Q's my right side, and what I'm going to do is I'm going to just put them together. And where do we get those from? Well, the Q comes from line 3, the P comes from line 4, and what are we doing? We're doing ampersand in. We're adding an ampersand between these two. We're saying I've got these two things, I'm going to put them together with an ampersand. So that's why we have ampersand introduction as the rule that we are citing. We look at lines 3 and 4. What numbers are next to 3 and 4? Well, it's just number 2. So now that we're here, now we have our square that goes with our conditional statement up to here. And so now that we've got the square, we can write our circle, which is m and n. What are the two pieces that we need to do arrow out? Well, we need our conditional statement, which is here in line 1. We need the left side, which is here in line 5. And what's the rule that we're using? Well, we're using arrow out because that's our main operator here in 1. Now we want to look at what numbers are next to 1, which numbers are next to 5, and we have 1 and 2. And so with that, that was the conclusion that we are looking to get to. So that is all of the proof that we need. We can get rid of 7 and 8 here, and we are just done. Let's look here at problem 5. So start the same way as I do all the other problems. Just start listing numbers down here on the side. Doesn't matter how many I list. If I list too many, I'll just erase them. Next, I want to put my premises from here, here, and here. I've got 3 of them. So I've got P and M. Arrow Q and L. I have M by itself. I have P by itself. I want to mark all 3 of them as assumptions. And this one gets 1, this one gets 2, this one gets 3. Remember, assumptions are where they get new line numbers. So I've got 3 different assumptions. Assumptions are where we introduce line numbers over here. That's where they all come from. So let's look at our conclusion. Our conclusion is L and M. Do I have L and M by itself anywhere here in the proof? No, I don't. So that tells me right away that I'm going to need to build it. I need to make L and M. And how do I do that? Well, my main operator is an ampersand. So I actually erase this L, put it in blue. I need the L by itself, I need the M by itself, and then from there I can do L and M with the ampersand introduction. So I see that I already have M right here, so that's one of them. Now that just means I need to get L by itself. So how am I going to get L by itself? Well, it's stuck here by this arrow. So I need to do arrow out to free up this L somehow. So what's our arrow rule? Well, I have a conditional statement here where I've got the antecedent on the left, the consequent on the right. I need the antecedent. Do I have P and M anywhere together? I don't, so I'm going to have to make it. So how do I make it? Well, I just need both the conjuncts. I need both sides, which I have them right here. So I need to put them together, P and M, like that. Where am I getting P and M from? Well, M is in line 2, P is in line 3. What am I doing? I'm introducing an ampersand between them, so I'm going to write ampersand in. I'm adding this ampersand. That's why it's introduction. We're adding the ampersand in. Now, what's next to 2 and 3? Well, the numbers 2 and 3, so the 2 and 3 will go here. With that, now I have my antecedent to my conditional statement, which is up here. So remember that if I have the left side of an arrow and the arrow statement, I can write the right side by itself. Like that. I need to write the whole right side. I have to write the whole consequent because the rule is being exercised on the statement. And the statement is P and M, arrow, Q and L. They're 2 sides and they both go together. So that's why we have to write both Q and L down here. Now, where are we getting that from? We're getting that from line 1 is where our arrow statement is. Line 4 is where our left side is. And what am I doing? I'm removing this arrow from that statement. I'm breaking the right side free and I'm doing arrow out. I'm removing the arrow. So what numbers are next to 1 and 4? Well, I've got 1 and 1 and 2 and 3 and 4. So I've got 2 and 3 here. I've got 1 from up here. And remember, I'm getting those from here and here. I see that I'm citing line 1. So what's the premise in what are the premises in line 1? What are the premises associated with line 4? Add them all together. Now, from here, are we done? Well, no, we still need the L by itself. So, done all this stuff. Oops, didn't mean to erase that. So I need the L by itself. Well, what's the main operator here? I still need to break this L free, so I can do ampersand out on line 5 to free up the L. Oops, it's wrong. There we go. So remember that I've got left side, right side. They're conjoined by this ampersand. What am I doing? I'm removing this ampersand. So that's why I'm citing ampersand out. Now, as I've mentioned before, if I wanted to, I could also write Q down here, citing the same exact line, because the ampersand out rule says I can have either one of them. I would just write the same justification and then cite the same premises. And it's totally fine. I don't need this Q in the long run, but I can go ahead and write it. That's no big deal. Now that I do have the L by itself, I'm good here. So now I just have to introduce both of the L and the M together. So I've got the L here. I've got the M up here. And so I'll just put them together. And what am I doing? I'm introducing an ampersand between them. And so I have lines 2 and 6. What numbers are associated with 2? What numbers are associated with 6? Well, that is 1, 2, and 3. Now we've reached our conclusion up here. We've brought it down here, and we've derived it from our assumptions, so we are all done with proof 5. So here on proof 6, we're going to start with the same thing as before. We're just going to list a bunch of numbers here. Doesn't matter if we use them all. We can always erase them. So how many premises do I have? I have 1, 2. So I'm going to write P, arrow, Q, and L. And then I'm going to write P and M. These are premises, so we mark them with an A for assumption. Associate them with the lines that they appear on. And now we want to look at our conclusion. What's my conclusion? My conclusion is an ampersand. Do I have Q and M anywhere in either of these premises? Answer is no. I need to build this Q and M. So how do I build this Q and M? Well, I'll need Q by itself, I'll need M by itself, and then I can put them together once I get them both separated. So let's look for them in our proof. I have my Q here and I have my M here. So the M I can go ahead and get out using ampersand out on line 2. So that would be pretty easy. But the Q is tied in with this conditional statement in line 1. So I need to be able to do arrow out. Well, let's start with what we can do. We can't do anything here to line 1 because we don't have the left side by itself. So in order to free up this conditional statement, if we want the consequent from this conditional statement, we need to get P by itself. Can we get P by itself? Well, sure we can. We have P right here. So first thing we can do is we could separate the P and M in this ampersand in line 2. What are we doing? We're removing the ampersand that we have here in line 2. What's the premise, or what are the premises associated with line 2? Well, it's just 2. And now I could do my conditional out. But the other thing I'd stated before is I need the m by itself. So how am I going to get the m by itself? Well, I can do the same thing that I did for p for m. It would be from the same ampersand statement. And so it's going to be associated with the same exact premise as before. And now we have our m. Now we just need the q by itself. So let's look back up here at line 1. I have a conditional statement. I now have its left side here. So I can toss it into this conditional statement. I can get the consequent. So I'll get Q and L from there. So what are the pieces? Well, first piece is my conditional statement. So 1. And then I need the antecedent, or the left side, which is here in 3. And then what am I doing? I'm removing the arrow in line 1. I'm getting rid of this thing right here. So it would be 1 and 3, arrow out. And what are the premises associated with 1? What are the premises associated with 3? Those are 1 and 2. Now I need the q by itself, which I can go ahead and get here. I can remove the ampersand like I did before. And what are we doing? We're removing it. Here's the ampersand. We're taking it out. And so now I've got q by itself, and I'm good up here. Now I can go ahead and build it. I have my m, I've got my q by itself. Also, let's look at what premises here are associated with line 5. That's 1 and 2. Now again, as I've mentioned on previous slides, we could go ahead and break that down a little bit further and go ahead and write the L if you wanted to. You would cite the same justification, you would cite the same premises just like that. We won't end up using that L for any reason, but you can do it because the rule says you can. But let's look at the conclusion that we're trying to build. We're trying to build Q and M. We have both of them now, so let's just put them together. They will be in 4 and 6. What are we doing? We're putting an ampersand in between them, so we're introducing the ampersand. What are the premises associated with 4? What are the premises associated with 6? Well, those are 1 and 2. And that is all that we need to do. I'm going to erase this 9th number here. Again, don't need this line. You don't have to write this line. This line did absolutely nothing for us. But if you want to use the rule to its fullest extent, you can go ahead and put it in there. So this proof could either be 7 or 8 lines. It doesn't matter. But that is proof 6. Now let's look at proof 7. Starting like I have before with listing all the numbers. Doesn't matter if I use them all. How many premises do I have? I have 1, 2. So I have a P. Oops. Need the arrow in there. P arrow, Q arrow, S. I have a P and Q. These are premises, so we'll mark them with A's. We'll associate them with the numbers that they appear on, so 1 and 2. Now, let's look at the conclusion that we're trying to derive. Our conclusion is S. Do we have S by itself anywhere? The answer is no. It's locked up here in this conditional statement, which is within a larger conditional statement. So what's our main operator? Our main operator for this statement is this arrow. We have this as a left side. We have this as a whole thing as a right side. But we know to get to this S, we have to free it up from the first conditional, this P arrow Q arrow S. So we have P arrow, Q arrow S. So we need to find the antecedent, or the P by itself. Well, we don't have it right away, but we can separate this ampersand into P's and Q's. So we can take this ampersand, we'll break it up into a P by itself, 2 ampersand out, 2, there's only the number 2 associated with it. And then we could do the same thing with Q, right? Q here, it's coming from the same ampersand statement there in line 2. What premises is it associated with? It's associated with premise 2. Then let's look at what we have. Well, we still want to get this arrow out. Do I have the left side? Well, now I do. It's here in line 3. So I have the conditional statement. I have its antecedent, or its left side. So I can go ahead and do arrow out and write the whole right side down here. Q arrow S. Where am I getting that from? 1 is my conditional statement. 3 is my antecedent. What am I doing? I'm removing that arrow in line 1, so I'm doing arrow out. What numbers are associated with 1? What numbers are associated with 3? That is 1 and 2. So here's 1. Here's the numbers associated with 3 right there. So we're closer to getting to S, but we still don't have S by itself. Let's look at what we have now. Now I have another conditional statement. And there's the S that I'm looking for. So how do I get rid of this arrow in between? Well, I need the conditional statement. And then I need its left side, which I have up here earlier in the proof. So to use my arrow out rule, I just need the arrow statement itself, which we see in line 5. We need the left side, which we see in line 4. And then what are we doing? We're removing the arrow in line 5. And so we are just going to write S by itself. What number is next to 4? What numbers are next to 5? Well, that's 1 and 2. And that is all that we need to do. Because again, that is the conclusion that we were given at the beginning of the sequence. So another point to mention after I erase these extra numbers is you saw that I wrote the 5 here first, and then I wrote the 4 here on the other side. Remember that you could have just as well wrote 5, 4. It doesn't matter the order in which you cite the line numbers you're using, it just matters that you cite the right line numbers. So, and it doesn't matter the order in which you cite them. I usually just cite them in numerical order, just a habit of mine, but you can write them in either order. But that is proof 7. Now we're on proof 8. Here we are going to just start by listing numbers again. How many premises do I have? I only have 1. So I want to write it out here on line 1, like that. It's a premise, so I'm going to put an A next to it. I know it means assumption, which seems counterintuitive. Why is it not a P? But it's just the way that the system works that we use. We just mark it as an A for an assumption. Now let's look at our conclusion. I'm looking for T and P. Do I see that anywhere in the proof in that one premise written exactly like that? No, I don't. So I know that I'm going to need to build it. So how are we going to build it? Well, we need to find the t by itself, we need to find the p by itself, and then we can introduce the ampersand between them and build it that way. I don't have any of these letters by themselves yet, so let's just see what I can do here on this first premise. First things first, let's identify the main operator. Our main operator is our ampersand. So what's our ampersand rule say? Our ampersand rule says that I have a left side and I have a right side, and from the ampersand I can just write either side. So I'll write the left side here. Where am I getting that from? I'm getting that from the only premise that I've got. I'm removing that ampersand in the middle. It's going to come from line, or it's going to come from premise 1 there. And then I'm just going to go ahead and write the second part up here, Q and T. That. It's going to be the same exact justification because we're operating on the same exact line as before. Same premises being used, so there's that. Now, we've broken that one up as much as we could for there. Now let's look at our other two sentences that we just made. Well, these are also ampersands. And what am I looking to get? I'm looking to get T and P. So I can get P from here and 2 using the same ampersand out rules before. So from 2 and out, I can get the P by itself. And there's just the number 1 next to the line 2, so we're good there. So that is one thing we were looking for. If you want to, and I'll go ahead and do it, I'll break this one down further and I'll put the M here. I'm not going to need the M at the end of it, but I can cite it anyway because the rule says I can. So now that one's broken down as far as it will go. I do need the T, so I'll write the T here. Where's my ampersand that I'm getting that from? I'm getting it from line 3, ampersand out. And you know what? I'm going to go ahead and write the Q by itself. I'm not going to need it, but I'll write it because I can. Cite the same rules before. What premises are associated with line 3? Well, it's just the number 1, because there's only one premise in this sequence. And now I've got T by itself, and I just have to put them together. I'll clean these up just real quick. So I've got my T here, I've got my P here. Now I just want to put them together because that's what my conclusion is. T and P. I'm getting this from line 4 and line 6. And I'm introducing an ampersand between them. I'm putting this between them. I'm saying I have these two separate things. I want to make them one thing by putting them together with this ampersand. So lines 4 and line 6, sorry about that, only have the number 1 next to them, so that's all that will go there. And with that, we are done. We can erase this number 9. We've reached our conclusion, which was T and P. And just so you see it, we didn't need this line at all. We didn't need this line at all, but it doesn't make it wrong for including them. Again, having a longer proof is no problem as long as you follow the rules. Following the rules is the most important thing. So now to the 9th proof, we have, looks like 2 premises here. Go ahead and write all these lines out. Don't know if I'll need them all. Totally fine if I don't use them all. So I got 1 premise here, 2 premise there. So we'll write P arrow, Q arrow, M and N. That's our first premise, and our second premise is Q and P. We'll mark them with A's because they are our assumptions. They are associated with lines 1 and 2 because that's where they appear. Again, assumptions are where we introduce numbers here on the left-hand side. because we want to identify which premises we are including when we are exercising the rules that we use. So let's look at our conclusion. Our conclusion is N and M. N and M. Do I see that anywhere in the proof by itself? No. I don't see it anywhere written exactly like that. I see an N and M here, but I don't see N and M written together in that way. I see M and N, not N and M. So, how am I going to get to this conclusion? Just like we've done on previous practice problems, we need to separate N and M, and then we're going to have to put them together. Now, locating N and M, they're both right here in this line 1. Well, what's the main operator in line 1? The main operator in line 1 is this arrow right here. So what I have is a P and then all of this stuff. So whatever I'm going to do to line 1, I need to find the left side first, which is just P by itself. Do I have P by itself? No, I don't. I do have a P here, and that is going to be something I can get access to because I'll just take this line 2, I'll remove the ampersand, so ampersand out, and what premise is associated with 2? Just the number 2. I'm going to go ahead and get the left side and write it here in 4. I don't know if I need it yet, I haven't looked that far ahead, but it might just be good to go ahead and separate it out. Same thing as before because I'm citing the same justification here and here. They're both associated with line 2. Line 2 is only got the second premise associated with it. Now, let's look back at what we had. Our line 1 is the conditional statement, and we need the left side. Do I have the left side? Well, now I do. It's right there. So, I can get this whole right side using our rule for arrow out. And it's probably not going to be big enough. Let's do that. So what's in the circle? I've got Q, arrow, M and N, like that. Where am I getting this from? Well, this is where my conditional statement is. So conditional statement's in line 1. My left side is in line 3. What am I doing? I'm removing this arrow up here. So I'm doing arrow out. Now, which lines are associated with 1 and 3? Well, I've got 1 here. I've got 3 here, or sorry, 2 in line 3. So I'll put 1 and 2. Like that. Now we're still looking for N and M. We don't have it anywhere yet, but I do have this new conditional right here. Do I have the left side for it? Well, yes, I do. I have it right here. So same thing as before. I can use my arrow out rule because I have a conditional statement here in line 5. I have the left side here 4. So I can write the consequent here in line 6 like that. And that's going to be from 4 and 5, arrow out. What are the numbers associated with 4 and 5? Well, that's going to be 1 and 2. Now, let's get rid of these. I'm still looking for N and M. I don't have them by themselves. I have M and N, but it's not the same thing as N and M. When we are looking to prove something, we have to prove it exactly, and we have to follow our rules to get there. So what can I do? I can separate this out into M and N. Where am I getting that from? Well, here is M and N, and it's an ampersand out. And it's going to be the same thing for both of these lines. So what numbers are associated with line 6 here? It's going to be 1 and 2. Just like that. And what are we going to do? Well, now I have N and I have M, which just means I need to put them together the way that my conclusion appears, which is N and M. And where am I getting that from? I'm getting it from 7. I'm getting it from 8. And what am I doing? I'm putting an ampersand in. 7 has 1 and 2 associated with it, and 8 has 1 and 2 associated with it as well. But that is our conclusion. That's what we are looking to build. So just a reflection moment here on this practice problem. One good technique to do is to exercise all the rules that you can. You see, here we had this conditional statement. And I said, well, I need to break that down at some point. And so I worked to break that down by breaking down this ampersand first into its smallest, simplest parts. And, from there, what I can think is, this one's done. This thing in line 2, I can't do anything more to it. I broke it down to its simplest pieces here in 3 and 4. And with that, I then can look at this line 1. And I have this conditional statement. And what did I do? I used this, and I broke it down into its simplest parts. And I can think to myself, I can't do anything more with that. I already used the arrow out rule on line 1. Nothing else I can do with line 1. So, clean this stuff up a little bit. So what you would be thinking is that I've got line 2 completely broken up. I've got line 1 broken up to this point here. And then you might say, well, now what can I do? I can break this thing up. And so you did. You used your arrow out rule right there. And then you could say, there's nothing more I can do to this. I've used my rule to do my arrow out, just like I did up here. Just like I used the ampersand out, and I broke it up. Then once you got to this point with the M and N, you broke it up into its simplest parts here. And once you break it down to M and N by themselves, you could say there's nothing more I can do to that statement there in 6. So a lot of the things that we do in natural deduction is deduce things to their smallest part. We look at the main operator and we say, what's the rule to use, or what's the rule to get rid of that main operator? And we look for that in our proof. Is it always necessary to do those lines? No. Is it always going to be possible to do it? No. But when you're stuck, you should be asking yourself, which line have I not used a rule on? Is it possible to use the rule on it? Can I construct what I need? Is there anything that I can do to exercise the rule that I have for that main operator somewhere in the proof? And more than likely, especially here in the early going, the answer is going to be yes. And so it might be a helpful technique moving forward to think that once you use the rule, the out rule for something, you say, well, there's nothing more I can do with that line. Once we got to this point right here in the proof, line number 1 was no longer important to us. Line number 2 was no longer important to us. The only thing that we had to go off of was line 5. And so we just work our way down the proof, exercising the rules that we have. And as soon as we do an out rule on something, that line no longer really matters. At least here in the early going, if we get into more complicated proofs, maybe there will be instances in which we could construct proofs that will have to rely on those lines again. But that would still be a building phase. You can only ever use the rule that's associated with the main operator when you're breaking something down, though. It will always result the same no matter what. So as soon as you use the out rule on the main operator in a sentence, you know there's nothing more you will have to do to break that sentence down. You've already done it. So again, this is just a reflection on a technique that you can use moving forward. You can think about check marking and saying, I'm done with this line. There's nothing more I can do with it as soon as you use the out rule for it. But again, just an idea, just a reflection moment on how these proofs are sort of operating. So let's do problem 10 here. 2, 3, listing numbers to start with. How many premises do I have? I have 2. So I've got P, arrow, Q, and S. I got P by itself. These are premises, so we're going to mark them as assumptions. Associate them with the numbers in which they appear. P, arrow, Q, and S appears on line 1, so it gets a 1 next to it. The P by itself appears on line 2, so it gets a 2 next to it. And then we move forward. Now, what's our conclusion? Our conclusion are all these ampersands together. Of course, I don't see that anywhere in the proof by itself. So what am I looking to do? I'm looking to get to S and P and Q to be able to build S and P and Q. Well, one problem we're going to face is that we don't have S and P by itself anywhere in this proof. So before we can even get to this point, we need to find S by itself and P by itself to be able to build this S and P. So let me rewrite this to give myself a little bit more space. So I just said I need to build the S and P first so I can get to S and P. And then I need the Q to get to S and P and Q. So we got to start up here to build this S and P, and then we're going to add the Q together, but we got to build the S and P. We got to build the S and P first before we can put S and P and Q together to arrive to our conclusion. So let's look at what we have here in the premises. Well, I have a conditional statement here in line 1. Do I have the left side for that conditional statement? Well, yes, I do here in 2. So from 1 and 2, I can write the consequent from line 1, that conditional statement. Where is this coming from? This is coming from 1 and 2. Which rule am I using? I'm using the arrow out. And what numbers are associated with lines 1 and 2? Well, they are 1 and 2. Now, I still don't have what I need. I have the P by itself, but I don't have the S by itself. So I need to break this up, write the S, and if I'm looking ahead, I need that Q too. So I'm going to write the Q down here. So 3 and out, 3 and out. Which numbers are next to 3? Those are 1, 2. And just so we're clear, you could have just as easily wrote QS. Doesn't matter the order in which you go. Could write S and Q. Could write Q and S. The justifications will be the exact same no matter what. The premises that are associated with them will be the same no matter what. The line number itself does not really matter. But so it doesn't matter which order you write them in. I was just thinking I need the S to make my S&P, so that's the first thing that came to my mind. I'll leave it just like this because it's totally fine. So now, again, thinking I've done everything that I can once I did my arrow out rule to this one. I've done everything that I can to this ampersand once I've done my ampersand out rule on both of them. So I still need to build this S&P first. Do I have S by itself? Yes. Do I have P by itself? Yes. So we have everything we need, so let's put those two together. S and P. Well, what am I doing? I am doing an ampersand in. I'm getting that from line 2 is where my P is. My S is in line 5. What am I doing? I'm introducing an ampersand between them. Taking these two things and I'm saying both of them together. I've got them independent and I want them together. So S and P go together, and so I'm going to do ampersand introduction. What number is next to 2? Well, that's number 2. What lines are next to 5? That is 1 and 2. We don't have to repeat the 2. We just put the 2 there by itself. So that is everything there. Now we have this part. Do we have the Q by itself? Yes, we do. We have the Q by itself and we have the S and P together. So we just want to build that right there. So we'll write S&P, parentheses, because it has to be only one main operator at a time, and Q. We're getting the S&P from line 6. We're getting the Q from line 4. What are we doing? Well, we are introducing an ampersand again between these two lines. So we're going to write ampersand introduction. What numbers do we have in 4? What numbers do we have in 6? Well, we just have 1 and 2 that appear in both places. So we have everything that we need. Got to our conclusion, which was S&P and Q. And so that is the 10th problem of the problem set.